Hello, this is the Test 2 review. For this test you'll need your calculator, and there are no tables required for this test. First we'll review some definitions dealing with probability. A procedure is an activity in which the result is unknown until it's performed. We mentioned that just about everything in life can be considered a procedure because you don't know exactly what's going to happen until it actually happens. An outcome is a result of a procedure. A sample space is the set of all possible outcomes, and an event is a collection of outcomes. A probability, or definition of that, was the probability of an event A is a measure of how likely A is to occur. Mentioned this isn't a very rigorous mathematical definition, a very conceptual definition. Probabilities take values between 0 and 1. Probability of 0 means it's impossible to occur. Probability of 1 means it's certain to occur. Close to 1 means it's likely. Close to 0 means it's unlikely. 0.5 means there's a 50-50 chance. Now remember that a probability is an average in the long run. A probability does not tell you what will happen on any one trial of the procedure, but it will tell you what will happen on average after many trials. We talked about 3 different ways of calculating probabilities. Rule 1, what we call a relative frequency approximation. Here you perform the procedure several times and record the number of times that the event occurs. Your probability is then approximately equal to the number of times that the event occurred divided by the number of trials. And this is only an approximation because it's subject to sampling variability, meaning that what you get on one sample of trials may be different than what you get on a different sample of trials. And that difference will affect your approximation, and so that's why it's only an approximation. Rule 2 was a more theoretical approach. It did not require us to collect any data. It's based purely on theory. However, this can only be applied if all of our outcomes are equally likely. The probability of an event is the number of ways that the event can occur, and divided by the size of the sample space. So in order to do this, you have to list out your sample space, count the number of ways that your event can occur, and divide it by the size of the sample space. This is what the book calls the actual probability, or we call it the theoretical probability. Then we had the law of large numbers, which relates these two rules. It says that as the number of trials gets larger, the Rule 1 approximation gets closer to the actual probability from Rule 2. So as you do more and more trials, you get a better and better approximation. We also saw what we call the addition rule, which is a rule for calculating the probability that one event occurs or a second event occurs. So the probability of A or B equal the probability of A plus the probability of B minus the probability of A and B. This was the formal addition rule. Informally, it said that you had to make sure you don't double count anything. That's why we have to subtract off the probability of A and B. Now if they're disjoint, that means that the two events cannot occur at the same time. Then the probability of A and B was 0, so we don't have to subtract anything, and our formula reduces down to this. Probability of A or B is the probability of A plus the probability of B. So if you see OR inside of your probability, that suggests addition, but you make sure you don't double count anything. Similar is the multiplication rule. You use this to calculate the probability that one event and a second event occur at the same time. So it's equal to the probability of A times the probability of B given A. That's called a conditional probability. And that probability of B given A is the probability of event of B taking into account the previous occurrence of event A. So if you see AND inside your probability, you simply multiply, but you have to make sure that when you calculate that second probability, you take into the account the occurrence of the first event. Now related to this is the idea of independent events. Two events, A and B, are independent if the occurrence of one has no effect on the probability of the other. So in terms of conditional probability, if they're independent, the probability of B given A equals the probability of B. You could ignore the occurrence of A because it just doesn't matter. In this case, then the probability of A and B is the probability of A times the probability of B. Now, conditional probability, this we mentioned this a minute ago. B given A is the probability that event B given that event A has occurred. An example we did in class calculating this deals with this results from a marijuana drug test. And suppose we select one of the 300 test subjects randomly, find the probability that the person tested positive given that he or she actually used marijuana. So somehow we know that the person used marijuana. That means we're not dealing with one of the 300 people in general. We're dealing with only one of the 122 that tested positive. So that's our denominator there. Now, out of those 122, 119 of them tested positive, so that's our numerator. You do the arithmetic, that comes out to be 0.975. So we see that the numerator comes from the first part of the probability, the tested positive. The denominator comes from the second part, the used part. The complement of an event A, denoted by A bar, consists of all outcomes in which event A does not occur. It's the opposite of the event. We can calculate the probability of the event by taking 1 minus the probability of the complement, or we could switch that around. The probability of the complement is 1 minus the probability of the event. This formula we mentioned was useful because sometimes it's easier to calculate the probability of the complement than it is to calculate the probability of the original event. Section 4.7, we talked about counting problems, and that's where we can think of it as though we're selecting R objects from a set of N. In a permutation, that's denoted NPR. We're interested in the number of ways that I can make the overall selection. The order does matter. In a combination, that's denoted NCR, and the order does not matter. That's the main difference between permutation and combination. If the order matters, it's a permutation. If it does not matter, then it's a combination. The calculator command for these formulas is math and PRB, and you have the formulas for NPR and NCR both available there. Chapter 6 or Chapter 5, we started talking about probability distributions, which is a description that gives the probability for each value of a random variable. It's expressed in the format of a graph, table, or formula. In this test, we see them in the form of tables and formulas. Next chapter, we're going to see them in the form of graphs. A distribution is a table, and or it can be in the form of a table. If it's in that form, then the sum of the right-hand column must be exactly 1, and each of those probabilities must be between 0 and 1. With each random variable, we have this expected value that's called the mean. It's calculated by taking each x value times its probability and add them up. Okay. So the example we did in class, we calculated the expected value of the profit for that game to be negative 0.25. What it means is that if I play the game many times, the total profit divided by the number of times played will be a negative 0.25. And the more times that I play, the closer these two numbers are. Next, we talked about a specific type of distribution that we called a binomial distribution, and that describes a procedure that meets these requirements. The important one there is number 3. Each trial has only 2 events. That's where the bi in the binomial comes from. For a binomial distribution, n is the number of trials, x is the number of successes, p is the probability of a success in one trial, q is 1 minus p, and then p of x is the probability of exactly x successes among the n trials. We had a formula for calculating binomial probabilities. It's called a PDF, and here's the calculator command, a binom PDF. Now when you enter that in your blank home screen, you have to enter n, p, x. Now for a binomial distribution, the mean mu and sigma, standard deviation sigma, can be calculated according to these formulas, np and square root of npq. And then we can use those and along with the range rule of thumb, which said that the maximum usual value is mu plus 2 times the standard deviation. The minimum is mu minus 2 times the standard deviation.